everybody. My name is Mandy Chessell, and I have the privilege to lead the Egeria open source project, and that will be the subject of this presentation. We're actually going to look at what does Egeria do, and also a little bit about the, well, actually mainly about the graph processing that is running behind Egeria that enables it to do what it does. There's a little bit more about me. So I've worked in the industry for over 30 years, and I spend quite a lot of time with different organizations, talking to them about their governance strategy, how they manage their metadata, how they make better use of data across their organization. And what I've noticed is that there are a number of common issues that organizations have as they grow their maturity in their use of data and governance. And that's really what the purpose of Egeria is. It's to start to solve some of the difficult integration problems that arise as we make more use of data and metadata. So the first thing to observe is that metadata is well recognized as a valuable capability for many tools that work with data. So what you have here are some examples of the types of metadata that can be captured by different types of tools. So let's start with the most basic. So if we think about a relational database, that is entirely driven by a metadata description of how the data should be organized and accessed. And we call this the database schema. And its role is to describe the structure of the data within the database and provide a language for identifying which parts of the data you want to retrieve, so for managing queries. Now that schema is accessible, and so we see a lot of tools that want to augment that particular descriptive metadata, the schema, with extra information. So next to it is the output from a profiling tool. So what a profiling tool is doing is it's looking inside the database at the values and says, well, you know, most of the values in this particular column in this table are blank, or they are from this set of values, or the average value is. So what they're doing is creating a characterization or a description of the data that is sitting in each of the columns, and we call that the profile. And so you can see in the picture here, the profile has been pulled off of all of the columns. And so that's a useful addition to knowing basically the structure of the data and what it contains. And then we have an analytics tool. So you've got a data scientist that needs to look at that data and then start to use that as input to their analytics modeling. And so again, they may well pull that schema structure from the database, and it's now in the tool. Another thing we can be doing is actually trying to describe the meaning of data so that people using data know exactly what it means. And that's typically done with a glossary. And a glossary is a collection of definitions of terms, like a dictionary, you could think of it. In some tools, you can just model glossaries, but in other tools, you can create a glossary and then link that to the columns in your data. And this is often the basis of something called a data catalog, where there's the ability to search for all the different types of data, all the different stores of data, either based on its linkage with a glossary term, or based on the known values, like the name of a particular table or the name of a particular database. As we get a bit more sophisticated, there are also tools that allow you to define governance rules and policies. So you might have a policy that says, if I've got personally identifiable data, then it must be stored in an encrypted store. Or if I have really sensitive personal data, it can't be seen by a data scientist and needs to be masked before copying it into their tool. And so these governance tools allow an organization to identify and specify exactly the rules for people using data in the organization. And some tools allow you to bring those together and connect them to the data so that this can be enforceable. And this bringing together of metadata is the sort of thing you would see in a data catalog and governance tools, being able to link them together. Because all the time they're in separate tools, there's a constant question about, is it correct and is it the most up to date? And are the different users of these tools seeing the same thing? Say, for example, that with the analytics tool and the profiling tool have run against the data and the database suddenly has a new table added. Well, that means that all the metadata in the two tools that have taken a copy are now out of date. So not only is it important that the tools can extract the metadata that they need and work with it, but they also need a way to be continuously updating to make sure it's consistent, it remains consistent. And the more we can link things together in something like a data catalog tool, the better. Now, in a small company, that's probably, one single data catalog tool is probably all you need, as long as everyone can agree which one it is. But in larger organizations, particularly where there's some decentralization, you see organizations that use a variety of metadata catalogs throughout their work. And so these create silos of metadata, which have the same problem as the silos that you might see with a particular set of tools. Now, what if we could sort of link this together more generically across the organization? So if we took that glossary that we've built and we use it to generate schemas, so structural metadata for common structures that developers are using as they're building new applications. So say, for example, the developer in this developer tool in the center of the screen is building an API with a microservice and a database behind. If their tools could pull standard structures that actually had tags to the glossary, their work would be much more efficient. So, for example, they might be building an API with a customer that returns a customer record. Well, if the tool could automatically use the description of customer from the vocabulary to create the JSON payload, then the developer is a lot more effective. The other thing and they're both faster to get the first version done, but they also avoid a lot of unnecessary rework because their JSON payload is complete. The other thing that happens is as those database schemas and APIs and microservices are pushed into the DevOps pipeline to go into production, then the fact that they are marked up with the vocabulary means that the DevOps pipeline can do special processing for depending on the type of data. So if it discovers, oh, wait a minute, this is managing personal data, then the database may need to be encrypted. The API may need to go to a secure gateway. So it can do different things based on that markup. And so here we see a set of tools that are where people are more effective and the pipelines are more effective because this metadata is being transferred between tools. If we now think about time passing and that application is now collecting data that's very valuable, and then the data scientist starts to pick up and wants to do some work to sort of improve customer loyalty or to provide a new value to customers, then they need a copy of the data from the application. And again, this is already a marked up schema, so we can pull that metadata into the data science tool, but with knowledge of the types of data. So the data scientist is more effective because they know what the data means, and any special routines that are needed to, for example, mask the data because it's not appropriate for that data scientist to see that particular type of data, that can all be automated as well. So I hope what you can see is that the more we link things together, the more we share metadata between tools, we see that different professionals can become more effective in the organization, and the level of automation and assurance that data is being processed properly can be increased. And that's really what Egeria is all about. It accepts the fact that there are very powerful tools that people use across the organization that are suited for a particular type of professional, and they use metadata. And that metadata is often sort of common metadata that is needed by all of these different tools. And so Egeria's job is to provide that sharing of knowledge between people and the tools and processes that they use, so that the organization can work more efficiently, and we're not forcing everybody onto the same tool in order to create that metadata sharing. And if you thought about it, think about it, we've actually been trying to do this for many, many years. And there have been different approaches, for example, forcing everybody onto the same tool or onto a suite of tools for a single vendor. Maybe standards that have been documented that every vendor implements, or copying metadata between tools, which is very difficult to maintain the integrity as you move things forward. And the thing that is typically the most effective but the most expensive is managing and creating point-to-point integrations between specific tools. So what we've tried to do with Egeria is to say, well, this is an important problem, it needs to be solved, but we need to do it better. And it's not something a single company can do. So I work for IBM. We have a lot of different products that use metadata. And we've tried to solve it ourselves by providing open APIs and allowing our customers to integrate metadata. But the reality is that vendors much rather work with open source, with open standards. So they're not locking themselves into a particular relationship with a particular business partner. And so this is where open source is very, very valuable. The other thing is that we mustn't assume that one vendor is going to be in charge. We need a peer-to-peer architecture where each technology can deliver the value that it contains. So we're not pushing everybody down to the lowest common denominator. We're allowing tools with different capabilities to collaborate and work together and share metadata as appropriate. The other thing that's important is that metadata is needed by teams that are not necessarily overflowing with lots of people with deep technical knowledge about how you set up and configure distributed systems. So we need to make Egeria as simple as possible and self-configuring, even though it's doing a very complex problem. And today's environments, we are using data in so many different environments. So we need to be able to scale right down to the Internet of Things type environment where maybe you're using small computers like Raspberry Pis, right the way up to sort of multi-instance, highly available cloud deployments that are multi-tenant, and are handling precious information about precious data in very large companies. And then we need to, within an organization, there may be every single set of scale. So all of these different installations need to be able to communicate with one another. The other thing is that metadata is not all the same. We have, even though two databases might be the same thing, and they're both two databases and would effectively be two records in a metadata repository, one for each database. The security required and who is allowed to know even that database exists and where it's located and what it contains may be radically different depending on its content. So each instance within the metadata environment has to be secured separately, and that security has to be maintained even though we're sharing that metadata with different repositories. So all of these have driven the design of Egeria, and one of the things that you'll see very quickly is that customization, scalability are all key parts of this capability. So how does it work? It basically is the white lines. It is maintaining that peer-to-peer exchange between the repositories that each of the tools have. So we're not trying to replace the repositories. Each of the tools continue to work pretty much the way they did, but they're just getting additional information being added to their repositories automatically, and as their repositories are updated with new metadata, that is shared with other repositories that are interested in it. So this project's been going about 2.5 years, and the team is incredibly innovative. We are having to solve problems that have not been solved before, and we are enabling capabilities that are only possible when you have this type of distributed metadata sharing. And one of those capabilities is the virtual graph of metadata that we've created. So often you see metadata as described, as shown as a graph, because we have this concept of facts and relationships between those facts. And the facts are added to the repository in a very sort of in batches effectively. So you don't sort of create that perfect view of your data landscape in one go. As people work with data, the metadata is constantly being updated. So and this is actually what I'm going to talk about today, is this virtual graph of metadata and how we maintain the graph across the very distributed and heterogeneous environment. And as I say, I was trying to think of a way of showing how metadata builds up in these types of environments, and basically knowledge of different data sets is added to one or other of the tools that are in the company that are being used by the enterprise. And then extra information like profiling tools and analytical tools get added, and more knowledge is added about individual assets. And then over time, the relationship between those assets is starting to appear. And as the company matures their metadata capability, the entire picture is appears to allow the business to understand the data, the governance team to be able to govern the data, and many different tools are able to operate on the data, bearing in mind that this is a constantly evolving landscape. And so here is a picture of a set of metadata, very similar to the tools that I spoke about right at the beginning, but shown all linked together. And typically the different colors that you see on the screen would be a different tool or a different type of process that adds that metadata into the metadata repository. And you can start to see, yes, this is definitely a graph of very different types of information. And what's interesting is that you might want to start with a glossary term and say, how many assets are storing data of this type? What is the quality of the data assets of this type, that store data of this type? So you often are doing comparisons based on elements that are not directly linked together, but are linked via several processes, several steps within the graph. That's what I showed you was sort of structural information, but one of the most commonly requested metadata-oriented use cases is something called lineage. And so if you imagine you're looking at a report or you're getting an answer from an analytics model, and you think, well, that doesn't sound right. So that really doesn't look right. Where did that data come from? That's lineage. That's basically you're saying, I want to know what were all the stores and the processing that happened from the original collection of the data to its use within my analytics model or my report, for example. And the way that that's done is by capturing every time the data is processed, we capture that type of processing. And often it's done with different technologies. So at the bottom of this picture, you can see that here we got a Spark job that's reading from one data store and writing to another and doing lookups in a third. So that's a small fragment of the work that could be done on the data stores. The next picture here, we've got an API that's calling a microservice that's accessing a data store that's actually been populated by an ETL. So there's some updates happening through the API, and then the results are then being sent out on Kafka to be distributed to other systems. So you can imagine that there isn't a single process that owns the entire flow. And what we're doing with the metadata capability is that each of these different technologies tells what they know and captures what they know. And it's not just at the sort of Spark job level. Often we have to go right down to the data. So we want to be able to say, this field value, this value is wrong. Where did it come from? So the lineage is going right down to the individual fields within it. So if it's an API, for example, we need to know what the parameters were passed on particular operations that are being called in order to be then able to then link that down, and maybe it's fed into a process, and the process may have multiple levels of function. It might be completely opaque, and we just say, well, we pass this data in and we get this data out. Or it might be that that there's some detailed logic that's been modeled. So this is typical for ETL engines, for example. And so the job of the lineage capture is that each technology contributes what they know, and the metadata repository, or the metadata service, in this case, Egeria, is responsible for what we call stitching it together. And sometimes it can be done by automatic matching if each of the technologies refers to the data stores that they're working with in a consistent way, which sometimes is true, but it's not always true. And other times it takes a steward to actually say, well, this name is the same as this name. And so any time, so these two things can be considered the same. And from that, we are then able to bring the full story for firstly, where did this data come from? So that's reading backwards down the lineage graph. Or if I change this Hive table, for example, in the middle here, what's impacted? Or if the ETL job that filled this Hive table failed, how long have I got before that incomplete data is then distributed by, for example, the Spark job that works off the Hive table? So you start to know how long you've got. What are your, how long do you have before that corrupted data, or that incomplete or inconsistent data is then distributed further? And this is a critical part of Lineage, particularly in organizations that have made very good use of automation to manage data distribution. So Lineage is an absolutely critical part of a large data-oriented organization. And I talked a bit about the stitching together, and this is basically showing the lineage mapping relationships between a process that's reading a CSV file, which has two columns in it, and those two columns are being read by the process and operated on. So this is how we would be able to trace individual elements. And this is really a big picture of what we're trying to get to, is that if you see the user that's looking at two reports and it's saying, well, these should be the same value, but they're not. But looking back through the lineage graph, you can see, well, actually, the one in red has input from a lot more systems than the one in gray, and that's why the values are different. So even on the report, they look the same, but actually they mean very different values. And that's often why regulators ask for lineage, so that they can be sure that they're being given reports with the correct answer. And actually that includes all of the data. Now, as I said before, the purpose of Egeria is that even though this supply chain may use lots of different technologies, and each of the teams may use their own metadata repository, we actually want to be able to bring these together. And the first concept that we need to identify is, which repositories should be sharing metadata. You obviously don't want to share your metadata with the whole world. You want to make a decision on which would be sharing. So in this example, we have 3 metadata metadata servers that want to share metadata, and they have joined what is called a cohort. And so there's a metadata repository in the data lake. So this could be Apache Atlas. There's a metadata repository that's associated with the systems of record, so the transactional systems of the organization. And maybe that's tied to the ETL engine that brings all the data into the data lake and manages the movement of data between the systems of record. And then there might be another metadata repository that's very much more focused on governance that the Chief Data Office is using. And so definitions from the governance team needs to be pushed down and consumed by the other members of the cohort. And so, so this is basically saying that this group of tools need to work together. And it's possible for large companies for some tools to actually connect to multiple cohorts, and they will see the superset of the metadata being shared in each cohort. And the way the cohorts come together is, it's back to this automated configuring, is that the center of the cohort is actually a Kafka topic, and each server adds, when it joins, it adds a registration document to the Kafka topic. So here we've got server 1, which is adding its registration to the topic. Now, because there's no one else joined yet, nothing else happens. But then eventually a second server joins, and so this is server 2, and it adds its registration, which of course is picked up by server 1, and server 1 responds. And there's an exchange of configuration information and knowledge about the metadata that each of these servers supports. Once that exchange sequence is completed, they are now configured so that they can issue queries, basically federated queries to each other. And so here you see that blue metadata is now appearing on server 1 on the pink metadata user interface, and pink metadata is now appearing in the blue user interface. And that's, you could leave it like that, but because there are some metadata that's used a lot for performance reasons, we can also, behind the scenes, metadata can be replicated between the different repositories. This is also very useful if server 1, for example, the pink server, actually doesn't have the capability to issue requests to server 2. So by having this background replication, server 1 is then able to work with server 2's metadata without any change to its function. So that's basically the setup. And the next question is, how do we represent metadata in a way that 2 completely different metadata servers can work together? And this is where the graph comes in. So the way that we represent metadata and what's actually exchanging, both in the API, the federated query API, and the the flow across the topic, is this structure. So all the facts, like this is a database column, this is a database table, this is a glossary term, are represented as entities, and these are the nodes or the vertices in the graph. And then we link them together to say that this glossary term and this column are related, and that's a relationship which may have properties associated with it. And then we have another thing which is very common in governance, which is called the classification. And this is basically extra information. And it might be something like this data is sensitive, or it might be it might be saying that this asset is reference data, or this asset is very significant for business reasons, or it has this security, or it came from this business unit. So there's lots of different ways in which we may want to classify a particular piece of metadata. So we describe all metadata using this structure, and these are the elements that are stored in our graph repository, and also that flow across the links between the different repositories in the cohort. Now, that would be quite boring and also difficult to actually make sure that the metadata was exchanged in a consistent way. So on top of that, we add about 500 types of metadata that are in common use in most organizations. And they span the assets themselves, the glossary, governance, lineage, the infrastructure that the assets are hosted on, the metadata discovery, which is that profiling, models, reference data. So these are things like valid values and approved structures, as well as collaboration. So people providing feedback and comments on the different assets as well. And when we look at the types, they form a type graph. So not only are the instances of metadata represented in a graph, but also the types are, because there are types of entities, types of relationships, and types of classifications. And so when we store things in our graph, or when we flow them across the metadata, each graph element links to a particular type. So this entity is a database column, for example. And so what's happening inside the cohort is that we're shuffling stuff around as needed. So here we've got two repositories. The pink one has a database column in it, and the blue one has a glossary term in it. And it might be that in the pink environment, they want to actually create a relationship between the database column and the term. So how do we do that? Well, the first thing we can do is we can shift the glossary term into the same server as the database column, so that we can create a relationship between the two. And this is fine as long as the server one actually supports glossary terms. You know, and this would work if server one then wants to update the glossary term. Egeria will automatically route that update to server two, and then the resulting update would be managed by server two, and then the update would be replicated back to server one. And this is how we avoid update conflicts, by making sure that only the server where the element was created is allowed to update the actual element itself. Now, this situation occurs if, for example, that neither server can support the other's metadata type. So it might be that they've never been designed to support this. And what we do is we take read-only copies of both pieces of metadata and then store the relationship in a third server. So in a cohort, we always have an Egeria metadata repository, and it's responsible for storing everything that doesn't fit anywhere else. So in this example, server 3 would probably be an Egeria metadata repository that's managing the meaning relationship. And you noticed the relationship is now stored in a completely different server to the others. Any updates to it would be routed to server 3, irrespective of which user or which server requested the update. And it doesn't matter whichever way we store it. If you ask for, tell me the glossary term for this database column, or tell me the database columns associated with this glossary term, however we've stored it, the results will always be the same when you query through the Egeria's federated query, because as the query will be distributed and the results assembled automatically by Egeria. And this ability to add metadata to existing elements is extremely important when we add governance, because there are a lot of tools that have no governance ability at all. And so the ability to just add classifications to entities that are stored and managed in different servers means that we can extend the capabilities of the tools that are in deployment with important governance classifications and relationships that can then be used by DevOps pipelines and other types of provisioning tools that are moving data between different environments. So here's an example. At the base here we have, let's have a look at the time. Yeah, at the base here we have some data, and then we talked about databases having schemas. So this is the schema on top. And then on top of that are glossary terms. And then in the glossary, it's actually been linked together so we can see what is part of an employee record, for example. And then finally, we've added a classification to compensation plan, which is a glossary term, to say that it's sensitive. So from that, we can map all the way down and understand that salary in this data record that's shown at the bottom is actually sensitive data. And this is how a provisioning engine could then say, well, okay, I'm going to actually mask that whenever I pass it to a data scientist, for example. So that's really why it's so important to be able to piece together this graph and from different repositories in order to create a governance environment. The other thing that's quite interesting is when we are moving metadata between different catalogs is that the granularity might not be the same. So the other things that we store in the Egeria graph are the identifiers that allow us to show the many-to-many mappings between instances in different metadata repositories. And all of this, again, is handled under the covers by Egeria so that when you query either on the external identifier or on the open metadata identifier, you'll get the right values back. The next thing that's really important in this graph environment, this distributed graph environment, is we talked about lineage of data, but it's also important to know where metadata is coming from, because again, if it's wrong or it's out of date, we need to know where it is located. We also need to be able to identify which server is allowed to update the metadata, and we call this provenance. And you'll see if you have a look at the structures of the graph and the nodes in the graph that we send around, the provenance is very clearly identified, so it's always possible to locate the original source of data and also to know where updates can occur. Finally, we have to allow people to see this metadata, and the users of the tools will see the metadata in the way they've always seen it, just by using the tools. But if you need to see what's actually going on in the cohort, or to understand what's been replicated into a particular repository, we have an interesting graph tool called the Repository Explorer that allows you to search for a particular piece of metadata, so that glossary term or that database column, and then see how it's connected together. And you can either say, show me from a enterprise or a cohort level view. So it will be using the federated queries to stitch together the complete map or the complete graph of the metadata that's there. Or you might say, okay, no, just focus on a single repository, and then it will show exactly what's been replicated into that repository, which is important when a particular repository can't do federated queries, and you want to be sure that the users of that repository actually have all the metadata that you expect in its store. So this is the Repository Explorer. We also have an Explorer for the types, so you can see the graph of the types that we have, and another that allows you to look at the deployment, which is also a graph-like thing. So you can see which servers are connected to a particular cohort, which governance servers are pulling metadata in and out of a particular repository, and which users are connecting to which interfaces in this environment. And so those are the sort of three sort of ecosystem type tools, and we also are building more graph-oriented end user tools as well to allow organizations to look at the lineage that's being consolidated from all the different repositories that are collecting lineage for their own piece, so that we can see the full end-to-end lineage of the processing that's happening. So how are we doing on time? It's just a little bit longer. So we have quite a number of vendors that are interested in integrating Egeria into their tools. And as an open source team, we are working with other open source projects to bring this together. We work very iteratively in terms of trying to make sure that everything we do is completely open, that people can be involved in any stage of any piece of work that we're doing. And this has created an incredible team spirit, but also a very innovative project as a result. the way we're building the product is, or the project is, sort of, we've focused a lot on the sort of the platform that gives us that ability to do the metadata exchange and manage its integrity. And then the user interfaces I showed you are being built on top. And then on top of that are the more sort of business-oriented capabilities. And I think I've told you this. Why is the Death Star there? That's because when you look at our code, we have some that's completely working and others that are in different stages. And every component is marked with whether it's in development or it's actually ready to go. And this is really our status. So there's a lot of green. The green is rising from the bottom and coming up, because obviously everything on the top needs to be built on the stuff on the bottom. So the focus has really been on maintaining integrity of metadata as we exchange it, defining the types, and enabling all of the mechanisms to host different connectors to different technologies. As we move forward, the focus is moving much more onto building connectors to third-party technologies, the user interfaces, and also the sort of business use of the capability, of this integrated ecosystem. Everything is in GitHub. So if you're interested in following along, there we are. And we also have tutorials. We have a dojo to help you get started with the project, as well as hands-on labs that show different user roles making use of different parts of Egeria. And there's some pictures in my charts, which you're welcome to see. So that is the end of the presentation. I think we need to move to give people a chance to ask some questions, and then that will be it. I think. So I'm switching to Slido, and hopefully there are some questions. Oh, we've got 4 questions, sorry. What are the main problems connecting graph processing with data lakes? So I've been talking about using graph processing for the metadata management. So how do you import metadata from Google Catalog into Egeria by using a standard connector? So basically there are 2 main approaches to bring metadata into Egeria. It could be either through what we call our integration daemon, where it is constantly querying the Google Catalog and copying into an Egeria repository that's then shared. Or the Google Catalog can be connected through what's called a repository connector that allows that it will then be involved in the distributed queries. So that's roughly what I've been talking about today. So there are basically 2 choices depending on how capable the Google Catalog is. So let me see. Oh, we've got how do you so all of the same. So basically each piece of technology, Egeria hosts connectors, and those connectors are specialized for particular types of technology. So there's a different connector for an ETL engine, for example, as opposed to an analytics tool, as opposed to a metadata repository. And the job of the connector is to translate between the open metadata API and types to the types supported by the particular technology. So the process of integrating a particular technology is exactly the same. The next one is, have you been applying your solution to domain-driven development approaches? So effectively what we are actually doing, each of those areas of metadata are different domains of metadata that are often a particular tool centralizes around a particular type. And so a lot of what we're doing and the way we use the graph is to allow metadata that has small overlaps between it to be connected together. So that's really how we do it. And does Egeria work with non-SQL configurations? Absolutely. Obviously, if you've got completely unstructured data, which is quite rare, as we're not gathering schemas. But if you take something like photographs and other types of media, then there is metadata associated with that, and we represent that inside Egeria too, and APIs and all different types of Avro schemas and things like that. So I think I finished my questions, and we're probably at the end of the session. So I will be on the Slack channel for a little while, and then we're ready to, if anybody's got any more questions.